I recently finished a project in Assembly to dynamically generate images, and whilst it was a challenge, there were 6 skills I used along the way to make the project easier. And you can use these skills too to level up your software engineering, regardless of what technology you use. So let's get into it.
Before I even started, I needed a development environment.
Somewhere I could type code, build, run, and debug. I created a dev container in VS Code, as this allowed me to create a fully reproducible environment that I could use off any machine, and I could share with other people. The nice thing about this is that it's a first-class citizen of VS Code, and even provides options for easily getting set up and running.
So this is my first skill for you: know your tools. By fully leveraging your tools, you can maximize your efficiency.
Now that we're up and running, it's time to write some code. But here I encountered the first technical problem of the project. How do you use floats in assembly? For this, we have to use the XMM registers, which allow you to store up to 4 floats in one register, and there's a whole host of instructions for working with these. For this project, I knew I needed to represent a point in 3D space, that is an X, Y, and Z component. It makes sense to bundle these 3 into one register, but now I'm faced with a choice. What order do I store them in? It might seem arbitrary, and ultimately it is. However, I found storing them in this order had the following benefit. Sometimes the unused section would accumulate junk, which needed to be zeroed out so it didn't interfere with other operations. So, by storing the unused section in the lower part, you could leverage a couple of simple instructions to easily zero it out.
And that's your second skill. Know your data structures and what they can offer you.
After writing some code for a bit, you notice something. These weirdly named instructions are hard to remember, and it's not immediately obvious what they do. So you pull them out into separate functions and give them meaningful names so they're easier to work with, and before you know it, you've arrived at skill number 3, abstraction. Bury implementation details behind semantically meaningful names. Even if they're simple, it'll be much clearer what their intent is.
Let's take a second to talk about what might be the most important, yet often overlooked skill is. Even with the best abstraction in the world, code can still be hard to understand.
So this is my 4th skill for you, commenting. Some people say that if you just write simple code that is self-documenting, there's no need for comments. But that's just an idealised view of the world.
The fact is, code is read more often than it is written, and when you do read code, you're trying to understand the thought process of the original engineer who wrote it.
The thing is that comments can capture design decisions, history, alternatives that didn't work, and ultimately help you understand why the code you're reading was written the way it was. So do future you a favour, and comment why you're doing what you're doing.
Getting more into the nitty-gritty implementation details, we often want to copy data into and out of these XMM registers, and we can do that with the mob apps instruction, where the A stands for aligned. And this provides us a trade-off. If the memory location you're accessing is 16-byte aligned, then it is efficient. Otherwise it crashes.
The alternative is to use the mob ups instruction, which will always work, but is always slow. The initial temptation is to use the aligned version because it is faster, but before you embark on a quest to make sure all your memory accesses are 16-byte aligned, stop and think, do I need the code to be fast? And more specifically, do I need this code to be fast?
Until you know your code is slow and you profiled it to ascertain that copying data into and out of these XMM registers is the bottleneck, then choose the path of least resistance to make progress.
And this is skill number 5, optimizations can wait. After some more coding, we've got some nicely defined primitives, some basic logic, and even a fancy red circle.
Now we need to assemble everything into a functional program. In higher level languages, you could create an interface for a shape and have a collection where you could store these and easily iterate through them. Such a thing doesn't exist in assembly, and whilst you could do it from first principles, the effort required is egregious.
Instead, I hard-coded the scene. I created just a single plane and sphere for rendering, and I knew there would only be shadows on the plane, so I only checked for shadows between the plane and the sphere. So this is your 6th and final skill. Be pragmatic. There's no such thing as perfect software, but there is such a thing as delivered software. So don't let the perfect be the enemy of the good. Thanks for watching. If you found these skills useful, then consider subscribing. And if you want to see how I made 3 ray tracers in 1 week, check out this next video.